Hello everyone, I'm Andrea Zugarini and today I'm going to present you Learning in Text Streams, Discovery and Disambiguation of Entity and Relation Instances. This is a joint work with Giuseppe Mara, Stefano Melacci and Marco Maggini. Here we face the problem of information extraction from a continuous text stream using only a few supervisions. End-to-end models for information extraction map text into a predefined fixed ontology of entities and relations. Those approaches are quite effective whenever the data distribution doesn't change over time and, more importantly, the ontology is kept the same. However, there are many scenarios like social networks, conversational agents, where actually new data always comes by, and along with the data, there also the ontology grows, including more entities, more relations, and therefore those methods cannot deal with such changes over time. So we propose an end-to-end model that discover, disambiguate entities and relations from text, starting from an empty knowledge base that is updated over time. So we have a stream of sentences that are organized into small stories. Within each story, there will be mentions referring to a set of entities and relations. The model will not know in advance which are the entities and relations involved within the story. Moreover, especially at the beginning when the knowledge base is empty, many entities and relation will be new to it. When the story changes, also the entities and the relation involved will change. We can see from the example that an entity can be referred by multiple mentions. Indeed, in story A, we have highlighted in red Clyde that is referred with a pronoun, the simple name, and also the full name. But at the same time, it can also be possible that the same mention is referring to different instances. And this is the case of Clyde in story A and the Clyde in story B, where the second one is likely referring to a different instance, which is a cat. The model architecture can be decomposed in 4 modules: the mention detector, the encoder, the candidate generator, and the disambiguator. So given an input sentence S, the mention detector will segment S into a set of non-overlapping fragments. For each fragment, the encoder will produce the subsymbolic representation of the fragment and a subsymbolic representation of its context. The candidate generator will exploit the subsymbolic representation of the fragment and the textual form of it to produce a list of possible candidates from the knowledge base. The disambiguator will finally determine among those candidates the most likely one exploiting the context of the segment, producing then in output the final predictions. The mention detector is trained with a syntax-based supervised learning approach, whereas the encoder, that is a character-level language model, can be trained in an unsupervised fashion. The output of those two models are a symbolic and non-symbolic representation that will be combined together and exploited with different attention mechanisms inside the candidate generators. The disambiguator will select among those candidates the one that is most compatible with the context of such segment, exploiting a prototype-based model that will determine the most similar entity or relation according to the given context, and will produce in output the prediction. We weight our model on 2 different datasets with 2 different ontologies and compare the results against a rule-based model and a deep recurrent neural network. Our model outperforms the disambiguation capabilities of both, and in particular that is much more robust than the deep recurrent neural network in not forgetting the previous data. Our model can be also improved rereading the stories without giving any further supervision, and this is effective in particular when the original quantity of supervised data is rather poor. Thank you all for the attention. If you have any question, please ask.